Hey smart people, Joe here, and this is a face. Except, not really. It's like 2 dots and a line, but I'm willing to bet when your brain saw this pattern, it said face. Think that was weird? Well, it was, but I've been seeing weird things everywhere. Like this washing machine has a face, this building has a face, and this mop has a big mad face. And this pepper is even angrier, probably because it got cut in half. Everywhere I look, it's face, 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 face. Has this ever happened to you? Of course it's happened to you. Seeing faces in non-human objects is something people from every culture experience. I mean, there's a whole subreddit for this kind of stuff. You and I are not alone. It's given us art, movies, and more memes than you can shake a face-shaped stick at. So what sort of collective malfunction is happening in our face-obsessed brains? Surprise, it's not a malfunction at all. Your brain is doing what human brains do. And this video is all about why and how your brain sees faces in faceless stuff. That's right, your brain's about to learn about itself. That's deep. Almost as deep as whatever subconscious weirdness makes you see phantom faces everywhere. The term we're looking for is facial pareidolia, our tendency to see faces in objects where there aren't any actual faces. Pareidolia is a cool word. It would make a cool band name, except I already count at least 6 bands on Spotify with that name, so maybe not. But I digress. As far as your brain's concerned, pareidolia is a feature, not a bug. We Homo sapiens are really good at identifying faces, and it makes sense. We're social animals, so being able to identify the mugs of our fellow species members, well, helps us build bonds and stay safe, right? On the flip side, quickly spotting the faces of things that want to hurt or eat us keeps us alive. So it's not hard to see why natural selection was like, yeah, let's keep this little skill and let's turn it to 11. Picking out faces, identifying them, and figuring out if they're friends or foes happens really fast. Like literally as fast as the blink of an eye. Quick sidebar. Here's an extremely condensed version of how seeing works. Okay, light goes in here, hits cells here, which send chemical and electrical signals along here, and those signals end up mainly here, in this part of your brain, the visual cortex. Why they put the seeing part at the opposite end from the eyeball part, I don't know. I didn't design this thing. Interpreting millions of electrical signals and trying to turn them into some coherent sensation of what the world actually looks like is hard work. It's a lot for one little chunk of your brain to handle. So the primary visual cortex works more like a traffic coordinator, dividing up that work. When visual data comes in, it sends some to other regions of the brain. Edges and lines, that's here. Motion, that goes here. Looking at words, that goes here. This division of labor, where different bits of visual information are sent to different processing areas, that helps our brains figure out what we're looking at even faster. But honestly, take a look around you right now. Take an honest look at all the stuff your visual system needs to interpret or ignore. It's a lot. To keep this visual information tsunami from piling up, our visual traffic controller sorts signals into 2 pathways, the where and the what pathways. Information like movement and where things are located in space is interpreted by brain cells along the where pathway. But figuring out what something is happens along here. Telling the difference between a bird and a bee, or an adult person or 2 kids in a trench coat, well, that happens here. But wait, how does your brain flag something as a face? Well, scientists have discovered that a pattern as minimal as 2 small dots on top of a 3rd dot, arranged in a triangular pattern on a contrasting background, that's enough for our brain to scream face. The spacing between the features or the details they do or don't contain, they aren't as important as just that basic arrangement. Our brain spots this pattern so fast that it's nearly automatic. Basically, you have a face-detecting hyperprocessor in your noggin. When your brain spots a pattern matching this basic face layout, specific brain circuits for face recognition light up first. But then these other slower object recognition processing areas catch up, reinterpreting that scene into what you actually see. What this means is when you see this, one part of your brain unconsciously screams, "Face!" And then other parts of your brain come in shortly after and say, "No, that's not actually a face." This is why when we experience facial pareidolia, we can switch back and forth between seeing the face and seeing the thing for what it actually is, because we're seeing both. Our subconscious, almost automatic face-finding ability, got researchers wondering, are humans born with our amazing face detection software, or do we learn it? To figure that out, scientists stuck babies as young as 6 days old in MRI machines to look at their brain activity. How they did that, I have no idea. But they found that the face-detecting regions of those babies' brains were already sending signals to one another, just like in adults. This is a big clue that Homo sapiens are born with a hardwired ability to recognize facial patterns, even when we're nothing more than squishy, pooping potatoes. But while those MRIs are definitely impressive, they're not 100% proof that we're born with it. Other researchers think our ability to quickly see and identify faces is something that we learn. We know from studies in animals that we are not born with an ability to see lines, angles, or movement. These are things that we learn to see by seeing them as babies. And study after study has shown that babies prefer looking at faces, partly because we're always sticking our face in their faces. And because babies are born with, well, pretty bad vision, to be honest, and the high contrast and movement of our faces are one of the few things they can see at that early age. And over time, babies learn that those faces are associated with things like comfort and food. That trains us to look for faces and identify different ones from a very early age. So yeah, scientists are still figuring out how much of our ability to see and recognize faces is learned and how much we're born with. But figuring this stuff out is important because it will let us develop ways to help the hundreds of millions of people living with prosopagnosia, or face blindness. That means maybe some of you watching this have face blindness. Honestly, it's really the only excuse for continuing to confuse me for Hank Green or Keith from the Try Guys, because come on, I don't even see it. Okay, fine, I do. We're also learning that people with Alzheimer's disease may have issues with the visual processing parts of their brain. And understanding how brain regions and our visual cortex work together could help us diagnose autism earlier, to help kids get the help they need. Because being able to see faces, it's a really important part of being human. You don't have to take my word for it. Ask evolution. Evolutionarily speaking, it's better to assume something is a face and be wrong than ignore what might be a face and, well, you know. Face recognition also helps us figure out what others are feeling so that we have more meaningful social interactions. That way we react one way if someone looks happy and another if they look sad or upset. Our ability to judge people's emotions by their facial features is so strong that we do it for objects too. It's why this person's neck is happy to see you, and these onions definitely are not. Projecting emotions onto non-faces can even shape human behavior. For example, a group of researchers in the UK found that we are more attracted to products that look happy. And companies can take advantage of pareidolia to sell more stuff. Another study found that cars that looked like they were smiling were better sellers than others. Unless you're a tough dude, bro, then maybe you want this mad car because it looks tough, and you're also tough, and you definitely lift and don't skip leg day, which we know because you drive a car that looks like this. Faces can even push us to change the course of evolution. Biologists realized that domesticated dogs have additional muscles in their faces that let them wiggle their eyebrows. Wolves don't have those muscles. It turns out that doggy eyebrows help them connect with us. And that helped them survive, since the cuter the puppy dog eyes, the more likely we were to share our fire and food with them. Adorable evolutionary manipulation? I'll allow it. So understanding how and why we see faces not only helps us understand ourselves better, but it can give us a deeper understanding of evolution too. So let's face the facts. we knows our brains love faces. So when you see a schnoz in your squash, a cara in a calabaza, a visage in your Volkswagen, or a cow in your bow, remember, you're just being human. Stay curious. Thanks so much for sticking around to the end of the video. If you did make it this far, leave me a comment with your favorite face emoji. And as always, thank you to everyone who supports the show on Patreon, including these fine folks right here, who I assume have wonderful faces. And you and your face can head over to our Patreon page and learn how you can support the show directly. Find out about new videos before anybody else in the entire universe, as far as I can tell. Well, there's a link down in the description if you want to learn more. We'll see you in the next video. Take it easy. It's really the only excuse for continuing to confuse me for Hank Green. Hey, smart people, Joe here. Nope.